Okay, let us go ahead and get ourselves going in this altered form, but hopefully this will still work out for you. Thank you for kind of allowing me to do this remotely today. I'm actually not all that far away, but kind of tied up in some meetings up in San Rafael. So thank you for your indulgence in letting us go ahead and try and do it this way. Okay, for session 13 today, there's a couple big things we want to be covering. I want to just kind of get some announcements out of the way and just do some special topics, but also specifically what we really want to do in terms of advancing the class forward and kind of new material is thinking about structural framing and really how we actually make plans and elevations out of our structural framing. Just really giving you examples of how to be approaching it as your structures are evolving and developing, how we ultimately are going to share that in the final presentations and kind of share them with each other. And then just kind of continue with the whole thread of the HVAC modeling and really for an HVAC, for a ventilation system, modeling the specific components, but then just not only modeling locations, but starting to think about them actively as far as analyzing the amount of airflow and how the analysis and modeling tools can actually help us to size all those elements. So similar to what we needed to do, or could do for structural elements, we could also do a similar thing for the HVAC elements. So that's kind of the rough outline for what's going on today. In terms of some specific announcements, the TAs have asked me to go ahead and talk a little about sort of the class 220C, the one that's going to be coming up in spring quarter and what's the difference there. The idea with 220C is we're actually going to keep on going with building modeling, but approach it in a slightly different way. We're going to look at the whole notion of parametric modeling. And that's the idea that really for any form that we're creating, we can attach variables to it that'll let us kind of change sizes, change slopes, change orientations. But to really think about our design as being a very pliable thing that can be controlled through parametric values, through variables that'll let us very quickly experiment with different forms. So it could be the slope of a roof, it could be a length of a building, a width of a building, it could be the orientation on the site, it could be, how many different pieces are part of a roof system or how many trusses are in a system, how big the radius is, a lot of different things that it could be. But what it's ultimately going to get into is that we can start very quickly changing and testing different forms by controlling those variable values. Okay, and as we're changing those things, kind of evaluate the designs that are being created from different criteria, whether it's building performance or the solar radiation potential or the amount of space or some measure we want to define about some aesthetic quality of the architectural design. It's all really about sort of doing parametric design and really scripting that allows us to do optimizations of forms. So, yeah. I know it sounds a little esoteric in terms of just kind of describing it all that way, but if we want to, we can dig in and give you some specific examples. But it's really all about kind of where so much of BIM modeling is going now. It's really supporting the old idea of computational design, that somehow we can use computational mechanics and scripting to go through and generate a lot of different forms and evaluate them very quickly, as opposed to doing a lot of hand modeling. Okay, so it's hopefully a very exciting new place where for people who want to continue with BIM modeling, a very kind of exciting place that a lot of attention is going to be going to in the next few years. So that's 220C. So that should be available in Access now. The other course that's also in Access is 220S. 220S and 120S are the kind of special purpose topics courses. So for anyone who wants to take any of the BIM modeling sequence in an online form, those are available, and we need to get people just access codes for those. So we just need to get those generated, and then people can sign up for that class too. So just kind of taking, again, what we were doing more during the fall quarter in 120A, 220A, but just doing it in an independent study way. Or the other way people tend to use 220S is if you have a very specific project, some special topic that you'd like to pursue. For example, we have someone who's working on kind of Revit API programming, looking at programming extensions to Revit using the API. That's another good way to do it. We could do it through 220S. So that you can propose a specific kind of special project you want to work on. And if it sounds good and we can work out a good arrangement for what you want to do, you can go ahead and pursue something in a more of an independent study, but a guided way. Okay, so any questions about upcoming classes and what's happening in spring quarter? I'm watching the chat window. That's why I'm looking down to the right-hand corner. Nope. If you're feeling good there, let's talk about the other announcement we wanted to talk about. That's the whole idea of actually bringing people up to, or inviting people to come up to Autodesk to actually tour something called the Gallery. We have a fantastic gallery up in San Francisco. It's at the kind of foot of Market Street, right across from the Ferry Building. It's full of lots of examples of just really cool and interesting design work. So building design work, immersive simulations, 4D simulations of like the Bay Bridge project, what concept cars of the future, just, exhibits that explain all about how 3D modeling gets used in movie making and game making and things like that. Just an awful lot of very, very cool stuff going there. I can send you a URL to the website for that. But touring it in person is actually a lot of fun. And we're thinking about trying to put together a special day to visit. So to have people come up just if they want to and just come see what's in the gallery. We could also go ahead and tour. There's a space called Tier 9, which is a big maker space. So all the highest end 3D printing and milling and laser cutting and water jet cutting equipment. If you're at all interested in digital fabrication from models, it's also a very cool space to work with. So we're going to put together some potential dates, and we were thinking about maybe trying to do something on a Friday, since that's a off day, or at least an unusual day from a lot of scheduling perspectives. But we're going to try and put out some dates and just offer that to people. So I think the big thing there is just really be on the lookout for that in terms of what's going on. We'll try and explain what that'll be about. And again, it'd be completely optional, but if people are interested in really seeing how a lot of the stuff is being used in some of the most interesting industry projects, there's a lot of cool examples there. Yeah, I know that PBL is there, so that's the part we have to work on there. Maybe Friday isn't such a good day. Thanks, Amy. So, 12 to 4 is kind of a tough time, Fridays. I don't know. I'm kind of good for almost like any specific day. Maybe we just need to send out a doodle poll. I know it's really tough to accommodate like a lot of different folks. So, yeah, good point. I'm trying to figure out what's going to be kind of a good time. We could definitely do for like Friday mornings or something like that if that's a possibility. Energy efficient buildings. Is that also Friday, 11 to 12? So by the time you end up with all these things, I think it's the problem we had with the scheduling of the class. There wasn't much of a time available in terms of doing that. I don't know. We've got to work on this. I guess best we can do is actually go through and, well, by the time you do those two things, that knocks out an awful lot of Friday. So Friday may not be the better day. So I guess we could do something like on a Monday or a Tuesday or just, I think all we can do is send out a Google poll to kind of see what's available to people. And it's one of those things, if we don't get it done this quarter, for everybody, for people who miss it this quarter, we can do something in that spring quarter too. And we'll see how things work out. So, so Lottie and Raj, why don't we go ahead and try to put together some sort of doodle, recognizing that Friday from 11 pretty much to 4 is out for a lot of people. We'll figure out what we can come up with. It's a tough one. Scheduling this quarter is actually one of the toughest things. Okay, thank you, Mr. Raj. Appreciate that. Okay, in terms of things we want to talk about today, there's several different things, but let's go ahead and get started with the whole notion of just, I like this whole idea of modeling special things and topics in that. So the whole idea of kind of creating custom and organic building forms is one that we've worked with a couple of individuals on their projects, but let me kind of share sort of what we came up with there, just so you can sort of see how it applies to, what you may be working on too, because it really is, kind of extends the vocabulary, or extends your toolkit of really what you can work on for modeling. So what I'm going to do is just pop over to Revit and do something kind of relatively quickly, just to give you a sense of, the flexibility of this stuff and how you might approach things. So let me go over to, I'm going to go popping over to Revit, and hopefully you all can still see that. And what I'm going to do is just open up a new project. And kind of go down a path of really kind of explaining how what unusual and organic forms often get modeled. So this is related very much to what we did in 120A, although there we kind of created relatively kind of standardly shaped buildings. They were only a little bit different in terms of what's going on. But here's the basic idea, that as we're going through and creating buildings, a lot of times, what we're doing with the standard tools like the wall tool, the structural tool, those tools, they tend to work with creating walls that are vertical. They have certain limitations to them. And every once in a while, as we're working, we want to create forms that are a little bit different, have a little more kind of interest, or just have a slightly unusual shape. Actually, let me do this. I'm trying to think about this whole notion of go to meeting. I'd like to put it in that other space. Not sure if I can right offhand. I'm not actually able to see the GoToMeeting window right now in the Windows environment. So if you have a question, please pop in just verbally. Just go ahead and let me know what's going on, because I can't read the chat when I'm kind of over here on the Revit side. So let's kind of talk about really how you can model some of those unusual things. So again, the standard wall tool, things like that, fantastic if you want to create vertical walls. Yeah. Even if you want to go through and create curved walls or walls that follow a slightly unusual path, that's all okay. But as soon as things want to start sloping or starting to go to any sort of unusual form, we kind of run into problems. We can't really do them with a standard tool. So what we tend to get into is the whole notion of doing form modeling. And form modeling just adds another step to the whole process, where we're going to describe a form first and then convert the surfaces of the form to the walls. So no worries. I think a lot of us have seen this, where I can go through under, yes? Yes. Yeah. Oh, hi. Oh, very good. Oh, no worries. Okay, excellent. Okay, very good. I think most people are online, so you're just checking on in. Beautiful. Okay, no worries. Sounds good. We're just getting started. Okay, so no questions yet? Just checking in. Okay, very good. So let us see. So we're over here. We're going to start creating sort of a simple math, and we'll actually use an example that's somewhat similar to what someone in class is doing. So let's talk about, this is actually close to one of the classes or things we're seeing in class right now. Here's the idea. We have someone who's actually trying to create a building where the walls actually fan up. They taper up, and they actually sort of follow an unusual profile as they do that. And that's pretty easy to do with masses. The idea with masses is really we can draw any sort of profiles, and then from those profiles, go through and create a shape. So let me just kind of make sure. What I'm going to do is go to the south elevation for a second. We have level 1 and level 2 here. Those are going to be pretty good in terms of defining some basic things. But if, for example, if I wanted the building roof to kind of slope in some unusual way, what I can go through and do is actually go through and draw a reference plane that will actually help me just in drawing profiles. To do this, let me cancel the math for a second, because I need to draw that outside. So I'm going to draw a reference plane, and I'm going to call this is just going to be, I'm going to choose that and say, hey, that's going to be my sloping roof plane. Okay, so what am I doing is actually just putting a plane in place that's going to allow me to draw. There's really nothing too special about that. But with that plane in place, I can do something like this. Let me, again, I'll still say that we're going to go through and create a map. I just wanted to get my planes in place before I do that. So here's my map. And I'm going to go to 3D just so I can kind of see things pretty nicely from the top. And what I'm going to do is as follows. I'm going to draw some shapes. Like I'm going to draw an ellipse shape, but it doesn't have to be an ellipse. It could be any of these sort of profiles. I'm going to draw it out of model lines. I'm going to put it on level 1. So this is going to be the lower boundary. So I'm going to just sort of draw something that looks like that. Okay. What I'm going to draw now is a second ellipse, or another shape that I would want to be at the top of the building. And this is all, again, in the sort of spirit of just kind of having an unusual form. I could choose model lines again, but I'm going to choose a different plane to place this on. What that's going to do is actually sort of draw the ellipse that I'm going to put here just on that plane. So it's going to kind of slope up a little bit. So if I put it on that plane, And then I can, draw the second ellipse. Okay, so I've actually just drawn two different ellipses now, one on the flat plane of the ground, one kind of up in the air sloping a little. A little hard to see them right here. Maybe I can orbit that around and you can see it better. Oops, looks like they're both actually on the same plane. I think as I was drawing, I must have lost something. Let me try that again. Get rid of the big one. I will come back over to ellipse. Say I'm going to draw it on the sloping roof plane. And now I'll draw it out. Okay, so as I go looking at that, yeah, it's looking a little bit better. You'll see I actually have these two curves that are doing something a little bit unusual right now. I can move those if I want to. It's just on the plane right now. But the big thing I want to do is be able to choose one and choose another, and from that, go through and say that I'm going to create a form out of those. And when I do that, I'm actually now creating some sort of unusual shape. Now that's the kind of shape that would be very unusual. You couldn't go through and do that using the standard Revit modeling tools. And we'll go ahead and finish that math. Okay, we now have this unusual shape to work with. Now, we could actually get sort of very arbitrary about these shapes in terms of how complicated we want them to be. So for example, let me go ahead and add a few more floor levels to this. I'll put some more floor levels in. I'll just offset them the same 10 feet. Actually, let me offset them 12 feet. I think it's a little bit better, 14 feet, to give me a reasonable floor-to-floor height. So I have some room for some mechanicals to go in here. So I'm going to offset some more at 14 feet. Just adding in here. There's 3, there's 4, there's 5, there's 6. 6 I misplaced. There's 6. Great. So when I am going ahead and placing planes, I can now, let me go back to the top view again. If I want to create another shape next to this, I can go through and, again, I'll say massing. Make an image place mass. I'm just going to draw some different shapes in here. So on level 1, I'll draw kind of simple circle. On level 2, I'll draw something that's a little bit bigger but offset. On level 3, I'll go through and I'll just do it on level 4 to kind of speed this up. Draw another circle over here. And finally up on level 6, I'll draw something. And it doesn't strictly have to be another circle. It'll go ahead and blend different shapes together. That's kind of more of an ellipse shape. Okay, so what can you do with all these? Again, I've got a bunch of different pieces. These are all flat, relatively flat, because I didn't put them on the sloping planes. I just put them on the round planes. But what I can do is just choose these. I'm going to just control-click to get them all. Say, create that form. Okay, now I have this very undulating surface in terms of coming up. So the idea is you can really create almost any surface you need to by just blending things together. And this is just called like form modeling. And we're sweeping or lofting together different curves to kind of create things. Now, these unusual forms that we're creating don't look very much like buildings right now. But if we want them to look more like buildings, what you can do is choose them. And you can say, I want to put some floor levels in. That'll just take that shape and divide it up into a series of floors. Gonna zoom on in there. So again, these are all just, these are called mass floors right now, just kind of breaking it up that way. But if we now want to go through and actually convert that more into a building, we can. We could go through and just under the massing insight, say that we want to choose a floor type. And then choose a type, whether it's generic or concrete or the metal deck floor, whatever we want. I'll choose and I'll control click and control click. What I'm going to be doing is just converting all these into floor elements. Okay. There's a little of a mess right now in that it sort of has the floor and the mass floor right on top of each other. That's why you see that kind of funny blue and gray intermixing there. But if we want to, we can also go through and create things like walls. So again, walls, you can be the generic white wall, or they make sort of a brick wall out of this back piece. That's a brick wall over there. Or if I wanted to go through and create a curtain system or something like that, I could again say massing insight, choose a curtain system, and I'll choose that surface and say, great, I want to create a curtain system out of that. It'll take a little work because that's quite an unusual shape. You know, wrapping a curtain system around that. It's going to black out for just a minute here. That's just my graphics card. Let's see how that actually does. It's still working. It's got a lot of little pieces to put in there. Okay, not so bad. Okay, so that is a building form. So we just want to give you a little bit of an arsenal to think about creating these forms. We can go through and create almost any form you want to. Just other slight variations you need to know on this theme include, oh, for example, this guy over here. This kind of looks almost like a sports arena or something like that. That might be something I'd see at the Olympics. Go ahead and kind of do this. Put some floor levels in there. Okay. Going through and making this building with this kind of unusually shaped wall, that's easy. We can go through and convert something like this to, for example, the curtain wall. That'd be fine. Massing insight. I'll make the curtain system out of that. If we want to go ahead and have this very simple curtain system, this 5x10 curtain system, which is just these rectangular panels, super, we can do that. Or if we want to, we can start giving it sort of more unusual shapes. For example, did I click it? I think I did. Maybe I missed it. Hang on, looks like it's generating that front side. A little flashing. There we go. Yeah, generating buildings like this, it actually works out pretty well. As we go through and do this, some complexities. One complexity we have to worry about is this whole notion of if you want to change that shape and maybe hollow it out or carve something away, and we can do something like that. Let me kind of show you that. What happens is if you really want to change that, and for example, I want to scoop away a part of the end of that ellipse or something like that, what I can do is go back and edit the mass. Okay, that is the actual mass itself. And if I want to carve away something, what I can do is, for example, choose something else. Let's see if I can go ahead and just put it down on level 1. Actually, if I was smart, I would go and kind of tilt it up because it's often very hard to see things in 3D in terms of whether you're accurately placing them or not. So I'm just creating a shape like that and rotate it back up again. What I'm going to do is actually carve away part of this shape of the building. So I'm going to take that, and to carve away, what I'm going to do is make a void. It's going to ask us sort of kind of this issue. It's kind of interesting. Whether you want it to be a sphere, because it has a choice at this point. Okay. what's happening now is I've taken a void and actually carved away the backside of this dish. That's looking pretty good. So at this point, if I want to go through and I've put that fantastic curtain wall on there, but it no longer reflects the surface, what I've got to do is this little update to face. Okay, and then maybe I can put a different curtain wall on this face over here now. But that's it. I just want to sort of give, for people who haven't had a sense of how you do this kind of arbitrary or these organic forms, how you get started with all this. It's really, there's incredible power in that kind of whole notion of doing this type of form modeling. And this sort of form modeling is actually the sort of thing that we often get into in the next class, in that these forms that were created, we could actually drive their size and shape using parameters to kind of determine, what the radius is, what the overhang is, and really come up with some very interesting buildings. These are the really odd and interesting architectural forms, and we can go ahead and drive these things programmatically and kind of evaluate a lot of different options as opposed to having to do this all with a lot of hand modeling. So let me just pause there for a second, because you could go into a whole deep discourse on this, but I just want to kind of give you a really relatively light touch on that and just kind of see if anyone has any questions about that to get started. Okay, just share that because some people just are heading off in that direction, and for people who are, it's just a really useful capability. Okay, so no questions on that one? Okay, if you're good on that, let's go ahead and move on down to our next topic, which is these structural plans, framing plans and elevations. And actually, what do we actually mean by that? So to work with that one, here's what I would recommend doing. Let's go ahead and, if you can, open up coursework and download for yourself. I go on back. In the Session 13 folder on coursework, you'll actually find a couple of different documents that, if you want to download today, would all be useful. Let me go back over to the 120B class. To actually get into the class, then we'll see the materials there. Okay, so in Session 13, you'll find a couple documents you can download. One sample structural project. Please go ahead and download that one if you want to follow along on this next piece about doing the structural framing plans. Sample mechanical project is going to show just kind of an overall kind of mechanical plan for the same project. Actually, a very useful one, just kind of take a look at to see the complexity. But we're finally going to work on this simple HVAC example. That's what we're going to work on together. So if you want to grab all three of those, please do. But I'm going to start out with a sample structural project, just to give you a sense of, kind of on a more complete project, really how these things and these different kind of views work together. So if you want to, please do download those, and we'll get going. So what it looks like over here in the Revit side is I'm going to go ahead and open, and I'm going to go to Session 13, and I'm going to go out and grab that sample structural project. Just give you a sense of what it looks like. This is actually one of the sample projects that comes with Revit, but it's pretty well developed. It's for a little office building, kind of like a office, I think it's what it is more than anything like that. It's a big concrete frame building. You can sort of see it's largely these large concrete plates. A little reinforcing kind of hanging around in there, but there's mostly these big concrete plates. You'll see there's some little what I'll call cores kind of hanging around at the end. Okay, this looks like it's a shear wall over there. It looks like there's a little bit of a core where I have some walls going in two directions. There's probably some stairs going on down through there, something like that. And down at the bottom of the building, you'd actually see that, where the big columns are landing, we have some different pier elements. Okay, the piles that are kind of transferring the load down into the ground. Okay, so it's not too bad as a basic structure goes. If I flip it a little bit, you can actually start to see, a little bit about how the construction's working. You'll see that on any individual level. Let me go ahead and just kind of make it hidden line so it's kind of white it out a little bit. You sort of have this notion of we have a slab, and within the slab there's a series of different kind of beams supporting that slab. But for the most part, it's like just big sections of slab with beams around the edges. Okay, coming down on those round columns. That's really what we're kind of looking at. So okay, if you're doing your building in concrete, your building may look something like this. Kind of a very simple rectangular kind of gridding system. So what do we actually do with that to communicate that and kind of share it out with other people? And typically what happens as we're thinking about doing something like this is we'll go through and either create a series of plans or elevation views, or really working together to kind of help explain the building. So plans typically, but then either elevations or sections can help explain it vertically, how this all works. And let me show you what I mean. So for example, if I come to the structural plans and let me go to, say, the second floor. That's what we have here. You'll see that on the section floor, there are all the different beams. And there's also the beams going in the crosswise direction. There's even the columns are kind of hanging around here. But they all have little tags associated with them. And here's what those tags all mean. Okay. Those tags can reflect a lot of different information. It's information that's coming out of the database of information about all the building elements here. So for example, if I click on this beam, some aspect of it's called C400, and I imagine that is some sort of a type tag associated with it. Okay, looks like it's reflecting the height. So what's going on over here? That's a C300. Yep, looks like it's the height, or the width, excuse me. So it's reflecting the number of millimeters in there. So there's different sorts of information that can be portrayed in these tags. Let me go to a different floor and see if we can add our own tags and give you a sense of how you do it. So here I am, I just moved up to the third floor. So if you want to go there with me, go to structural plans and choose the third floor plan, and you'll see that hanging around on the third floor plan, you'll see the kind of columns are there, the beams are there, but there's no designation kind of explaining what those different beams are. Now, if I was really good in terms of creating my constructural plans, what I would do is I'd go to the annotate and I'd put some dimensions on these, just because it is useful to be able to see that, oh, the dimension between all these different grid lines. And this is the way we typically do it. We'll just dimension to the grid lines because all the structural elements are hanging off the grid lines. So I'll put some sort of dimension out here, maybe another one that goes just overall. Okay, so that's useful information just to help us understand, all in metric. So what is that bay size? Looks like 6.5 meters, basically. Okay, so in terms of actually documenting the size of all these individual elements, here's the deal. I could put a lot of text on here explaining what all these different sizes here, but text is sort of inherently inefficient in that it doesn't actually reflect values from the model. It's just a text for what it is today. It's like a snapshot. So if we'd actually like it to have a live reference to what's happening inside the model, here's what we do. As opposed to just kind of putting text in here, what we tend to do is, we'll go back to the Annotate tab, we use something called tagging. And tagging is really a whole lot more powerful. Tagging says, go ahead and grab information about the building elements from the database and present that. And the cool thing about doing that is then, if the model element changes, if the database element changes, then you get the latest value. So it's always up to date with whatever the current value is. And that's really useful if you've been doing some structural analysis and the sizes change during the structural analysis, because then you don't have to go through and change the text. It'll automatically change as the sizes change. So that's a really useful way of doing things. One of the beauties of BIM modeling. So in terms of tagging, we can do it a couple different ways. We can do something called tagging by category. And what tagging by category is, it says, I'm going to go ahead and try and pull some tags for each of the different elements you point me towards. Okay, so I can go through and tag that beam, and I can tag that beam. I can decide whether I want to put a leader being that little kind of line that's connecting the beam. If I turn off the leader, you'll see I can just choose the beam itself. But what's happening now is I'm actually getting these designations that are coming really from the beams themselves. So I got these 400 by 800s. And for example, if I change that from a 400 by 800 to a 600 by 900, you'll see the tag changes too. So it's really kind of valuable and important that there's this direct connection between things. So does someone have a question? I heard a beep. So is that just someone coming in and out? Any questions about tagging? Because we're going to keep on doing some more stuff, but like, you just want to see if that's sort of making sense at a high level, that really rather than putting tags in, it'd be so much more, text in, it's much more useful to go through and put tags in. Tag that, tag that. You get the idea? Okay, if you like the idea of tags, let me take you one step further. Tags actually, this is a tag that has a big old box around it. I don't really like that so much. The box sort of distracts me. I sort of just like to make them standard, which doesn't have the box. Okay, it's just sort of a graphical choice. There's a little less clutter in the diagrams. Even on this one, if I want to, I can take off the leader just being that little line, and kind of shove it up closer to the beam itself. Okay, but again, it's a live tag. It'll stay live no matter what's happening here. Okay, but the truth is, I actually prefer not to go through and tag things individually, because it's just a lot of work, to go through and do all those things. So let me say standard there. Beautiful. Doing that. It's looking not too bad. What if, and you imagine this, you could actually just tag everything in the entire view, maybe even in the entire project, just by going through and using a single command. And that's what I want to show you next. Because it's kind of a very regular thing. I'm going to take out these old tags. Oh, I could leave them in there. It doesn't really matter a whole lot. If you would like to tag everything of a certain category, here's how you do it. So let me zoom on out. Got a lot of beams in here. It's going to take me a lot of time to tag all these things. What I can say is tag all. So right next to tag, I'll do that again slowly. Tag all, not tagged. Okay. We can go through and choose kind of what things we want to tag. So for example, if I want to do structural framing and I want to use, let me do by type mark standard, that would be unboxed. That'd be one way to do it. I can choose whether I go ahead and have the leader, okay, or not. I'm going to leave it off right now because I prefer not to. And I'm going to do only the objects, all the objects in the view, or only the selected objects. So you got kind of a choice about whether you'd like to do things that either they're sort of hanging off the edges a little bit, or you want to get all the ones that are in the current view. Now, in the current view, by that I mean everything in this third floor plan view. It wouldn't do the floor 2 ones, and it wouldn't do the floor 1 ones. You have to do it view at a time. But if you want to select them all on 3, I'll leave that selected. Say OK. And it just did a whole lot of work for us. Well, that looks like it was the wrong one. That's the, I didn't like that one. Let me undo that. Control Z. I like the one that actually has the family name. And let me see if I can kind of switch that out again. Tag all. Which one is it? Let me try the framing tag standard. See what that one looks like. That looks a little bit better. That's just the size. Now, you may be wondering what can show up in tags. And really, the answer is like most anything. For example, if I take this tag and I double click on it, I can edit it. And you'll see the tag is just a library part. It really is just a collection of information you want to show. And within that, we can go through and edit the label. We can choose which of the different variables, whether it's an assembly code or an offset or a fire rating or anything about it, any of these information pieces can be put in there. So if, for example, I don't want to mess it up too much. I would just pretty much leave it to the sizes there. But if you want to go ahead and put something else in there, you could. I'll bring it on over as a separate line. I'll put a break in there so it'll always kind of have on 2 separate lines. Say OK. And if I want to load that back in, and it's displaying different information. So what's going to happen now is it won't only be 400 by 800, it'll also be the assembly codes. But that is, tags can really display any information you want them to. Looks like for this one, is there anything for the assembly code? There may not be. That's, I think, there's nothing showing up. There it is. It is blank. Okay, so if it was C500, well, be that way. I have to choose one from my standard list. Still not? I think I have to go all the way down in the hierarchy. How far to beams precast? Beams cast in place. Try that. Yay, finally got one. That would actually be associating these beams with a specific part of the construction specification. Doing a little regenerating right now. A lot of flashing going on my screen. I'm not sure if you can see that so well in GoToMeeting. Okay, so we now have assembly codes associated with all those beams too. The nice thing is though, it all just kind of basically comes because we edited the tag, everything sort of picks it up. Now, these don't have it because those were actually a different tag code. If I went through and put it structural framing, not with end reactions, with start reaction, I think it's just that one. Yeah, there's the tag. Okay, and you can go through and change them that way. But the idea is that in your plans, between these designations, that just sort of have whatever the size code is, as well as kind of the dimensions, you have pretty much all the information at a high level we need to know, understand the structure. Similarly, if you wanted to, you could go through and annotate. We could go and get those structural columns. Let's see what the structural column tag at 45 looks like. Okay, so now it put them in there, the 450 millimeter columns. So that's an awful lot of information that showed up on the plan very fast, but that's actually pretty darn close now to what I would want to see as a structural framing plan. So, that's all there is. That's the difference between just having your kind of raw structural framing and making a plan out of it. It's typically adding dimensions and adding the tags to it. So let me pause there for a second and just sort of see if that sort of makes sense. What I think we'd ultimately want to do is just, by the end of the semester, or end of the quarter, excuse me, go through and, for, a framing plan for your various floor levels, just have about that much information. It's just the real high level, the dimensions, and kind of a little bit of information to understand what the sizes are. And hopefully that's not too much more work than what you've already done just in terms of doing the basic modeling. Let me just pause and talk about that for a second. Is that sort of making sense to people, or Raj and Lottie, get a sense of the room? No volunteers? I feel so lonely out here. Yes, I can. Okay, very good. Now, if anyone has any questions, please check in during the check-ins or something like that. But it's pretty straightforward. Hopefully, it's pretty straightforward. I don't know, but again, it's always straightforward until you try it on your own, right? but we'll go ahead and see. Okay, sounds good. So again, if anyone's having any questions, jump in, or either verbally or kind of just jump in terms of the chat window, and we'll try and keep those going. Okay. Then let me show just one other variation on that. If anyone ever says, hey, I would like to see a framing elevation or a framing section, let's show you what we mean. So I got some sort of elevation view, of something going on in here. If I want to make a framing elevation out of it, it's pretty straightforward. It's the same sort of thing. Really what I'm going to do is go through and just do annotate, and I can either tag them individually. Looks like maybe they're hidden right now. That's what I think the warning is telling me there. What I'm going to do is do a visibility graphics, insert a C. Visibility graphics, hang on. Let's see if my framing tags are in here. They're, I think, under annotations. I never remember where those are. Area tags. There are structural framing tags. I knew they were hiding. Okay, so there's that beam, and I can go through and tag some more of them. But it's really, in fact, let me just do it in a more, another way. Let's go, I'll cut a big old section through the building. So I'm going to just cut a big old section through the building. I'll say view. Let's section this thing. I'm going to flip it over the other way. Not too deep. Okay. So I've got a section of the building. It should hopefully be showing up over here somewhere. Seeing about where it's showing up in that view. Now I can get to it over here just by double clicking on it. Looks amazingly like a foundation. Okay. So in that same sense, here we are looking at it this way. If I would say something like annotate and tag all, and again, I'll get those structural framing tags. I'll do the camber one, even though there's not much camber information here. I'll say no leaders. Say all the objects. Okay. Interesting problem here, just so you sort of get a sense of what's going on here. There's actually several labels showing up there, and I'll tell you why that is. Let me Control Z my way out of there, just so you don't get confused by that. What's happening here is there's actually several beams that are kind of, one behind the other, and that's what's sort of getting me in trouble. So if that's happening to you, what you got to do is go to your section and just really pull back so you're not getting as many beams. I think in this case, I got more than one column line. So it was getting one beam in front of another beam. Okay, and now let's try that tag all and put that in there. Somewhere in there. Oh, I see what's going on. The ones that are crosswise to us are looking pretty good. The ones that are going perpendicular to us are the ones where it's all doubled up there. So maybe in this case, tag all is not the best strategy. Maybe I'm just going to tag them independently. So tag, tag, tag. Oops, wrong one. Okay, but hopefully you'll see that, yeah, it's really, once you have things in the database, both sort of relatively easy to go through and do this, but also relatively powerful in that, if at any time in the model someone decides to go through and change and say that, that beam over there, it really needs to be something else, you can just go through and change it in the model. So it's not a 600 by 900, or it came back from the structural analysis program that it was going to be something smaller. Yeah, and it changes for you automatically. So go ahead and take advantage of it. That's just really one of the beauties of the BIM modeling, is that all stays kind of completely intertwined and hooked, so you don't have to kind of worry about doing a lot of drafting. Once you set up this view, it'll always adapt to kind of reflect the current information in the model. Okay, let us pause there for a second. I'm going to go back over because I want to move away from just sort of the structural framing and get back into the HVAC side of things. So I'm just kind of pause there for a second and see if there's any questions about all that structural framing. You have a non-structural, hit us. For our building design, do you recognize having a core? What if we put a continuous core that goes all over because of the shape of the building? If you don't have a core, okay, typically think about what the core is. The core tends to have to do with two different things. One is providing some kind of lateral reinforcement. Okay, so a core is useful because it's just a continuous line all the way up and down. It's also usually good for putting elevators or stairs, something like that in there. Now, if the design of your building is just such that you can't put one going up all the way, that's super. You know, we can, as long as we take care of the stairs, that's fine to get them all the way up and down. For the lateral reinforcement, if we can't do it with like a concrete core, we just need to think about doing it with like a bracing system or some other system that'll let us transfer those loads all the way from the top down to the bottom. So if you don't have a core, that's okay. Just check in with the TAs or myself, and we'll see. There'll be some strategy that we'll need for bringing those lateral loads all the way down to the ground. And every building is a little bit different, but we can do a little consulting and advising you on that. So I think we'll be able to take care of it. It's just we have to take a look at the specific shape of your building and think creatively about how to do it. Any other questions about the structural side? Nope. Okay. No worries. But if you have questions, got to bring them to the check-ins because that's really what they're for, is to kind of like help guide you through some of these kind of specific things of how they apply to your building. So be sure to kind of bring good questions so we can give you some help on those things.